Okay, it's finally got to the last question on this November 23 exam paper for IGCSE Physics, Paper 2, and all the previous videos in this playlist cover questions 1 to 7, so this will be the final video. If you're one of my students, this will not be in the mock exams, as this topic relates to astrophysics, which is topic 8, and we haven't covered it yet. Okay, so the actual question is about redshift. Okay, so the question is about redshift, and redshift is a Doppler effect. It's a Doppler effect for light. So you studied the Doppler effect when you did the waves topic. So again, as I explained in previous videos, that in the GCSE exam, you will need to, they combine theory from waves because it's used, wave theory is used in astrophysics to analyze starlight. Okay? So once we know that starlight is giving off different radiation, visible light, infrared or ultraviolet or whatever, we can analyze it. And something called redshift is due to the motion of the light source. It can shift towards the red end of the spectrum rather than the blue end of the visible light of the spectrum. And when it is shifted to the red end of the spectrum, we can tell that that object is moving away from us. And we know what the light spectrum should look like from a star, for example, if it wasn't moving away from us. Okay, so that's why it's called a redshift. Okay, so let's go through the question. The diagram shows that the star, compared to where Earth is, so Earth is in the direction at the bottom of the page, so light is coming towards Earth, but the star is rotating around something. So star A and B, they're rotating around each other. So it says light from each star arrives at Earth. Okay. So as the stars move in their orbit, the wavelength, so they're kind of orbiting around the center here of the two masses. Okay, so they're kind of doing a dance in space. As the stars move in their orbit, the wavelength of light observed at Earth changes due to the Doppler effect. Okay, now you know from the direction of the orbit that they've given you that when it's going this way, the star, whichever star, when it's going in the upward direction, I should have put, when it's moving in the upward direction, then it's moving away from us. And when it's coming, when it's coming towards us, you could say it would be blue shifted. Okay? So red shifted will be on the right side of the diagram because the star is moving away from us. And on the left side of the diagram, the star is moving towards us, therefore it should be blue shifted. Okay, so that's trying to understand the theory. So they say add an X to the diagram. That's what they want you to do. They want you to add an X to the diagram putting it in red because it's going to be on the red side, to show the position of star B when the light emitted shows the maximum redshift. Okay, well the maximum redshift is obviously when it's moving directly away from us. Right now, star B is moving that way. But over here, it's going to be moving at the fastest rate away from us. So that will be the maximum redshift. okay? When it's moving away from us at the greatest rate, so it'll be at the side of the orbit of the circle, yeah? So when the star or the light source is moving away from the observer at the fastest rate, and that will be where I've drawn it on the diagram, marked by the X, okay? I'll rub out the other X in the middle, yeah? So it's this bit in my diagram, okay? Okay. This is not a very long question, by the way. It then says, here's the final part of the question, part B. So now that you understand what redshift is, light is received on Earth from a distant galaxy. The longest wavelength of light arriving at Earth from the galaxy is 561 nanometers. Okay, so that's the longest wavelength of light when it's moving away from us. If longer wavelength means redshift, because red is a longer wavelength than blue. It's the longest. So that'll be the maximum wavelength. And then it says that a lamp on Earth, I'm deliberately not making it in red, a lamp on Earth produces the same light, yeah, but this time with a wavelength of 550 nanometers. So if it's on Earth, it's obviously not moving away from us because we are on Earth. So this is the normal wavelength that it should be producing because it's the same light, but it's actually producing redshifted version of that light. So it's increased by 11 nanometers, okay? Now it says calculate the velocity of the galaxy. Well, if it's redshifting, the amount that it changes by, in other words, change of the wavelength, yeah, tells us how fast it's moving away from us compared to the actual wavelength. So the actual wavelength is the wavelength in green, 550 nanometers. So the change in the wavelength is 11 nanometers. So it's changed by 11 nanometers due to the motion. It should be 550. So 11 out of 550 parts will be the ratio of the velocity of the galaxy compared to the speed of light, which is given to us in the question as 3 times 10 to the minus 8, 3 times 10 to the 8 meters per second. So the only unknown, yeah, in this part of the equation is velocity of the galaxy. So if you change the subject of the equation, you'll get this form of the equation, and it will give you the speed of recession, mean moving away at approximately to two significant figures, 6.0 times 10 to the 6 meters per second. They're giving you the units, so you don't need to worry about that. And that's how astrophysicists can work out when something is moving away from them and moving towards them. And since the majority of galaxies have this redshift effect, we then have evidence that distant galaxies are moving away from us. All galaxies tend to be moving away from each other, which is why we believe that space must be expanding. Okay, so that's the final question of this paper, and you'll see that the paper is 75 minutes and out of 70 marks. Yeah, so 75 minutes for 70 marks. And if you remember, paper 2 was 2 hours and 110 marks. So they're giving you slightly more than 1 minute a mark. So paper 2 is actually a shorter paper, but it seems to be more mathematical and more analytical. So it's really, students do find it a little bit more tricky, but that's why you need to practice as many past papers as you can between now and your real exam in the summer. Okay, well, thanks for watching. Again, please show your appreciation. Like each video you watch. If it helps you, give it a like, give it a thumbs up, because that's how YouTube works. The algorithm is by how many people are watching it, how many people are sharing it, and then it goes to the top of the list for other students to see them. And share it with your friends, especially if they're in other schools. We want to spread the word, and make sure you subscribe, because obviously as we go through the year we can put more videos on there, especially if they don't give me too much work to do with non-exam groups. Then I can help students who really need help when they're preparing for their exams. Okay, thanks for watching. See you in the next set of videos. Bye for now. And Happy New Year.